Thank you very much, Mark. And thank you everybody for attending this presentation and the Accelerator for hosting us. Let me share my screen with you. Do you see my screen here?
It looks good.
Yep.
We see the presentation background.
Okay. Yeah. Let me then put it in presentation mode. Okay. Here we go.
Perfect.
So thank you again for hosting this Puerto Madero project that we have been involved for several years now. And I want to start with the project team that we have. The architect is Torres de Malaga, SSAs in Bogota, Colombia. Real estate investment firm is Consinfra, LLC in Wilmington, Delaware. The developer is Torres de Malaga, as well as the general contractor. They're a seasoned builder and developer in Colombia. The urban development was made by SWAM SAS in Bogota, Colombia. The CPHC is the E+ building here in Montpelier, Vermont, USA, and the project feasibility study is being done by Phius. So the project, 42 acres, 170,000 square meter site located 4.5 miles, 7.2 kilometers from the heart of Cartagena, Colombia's walled city, the one you see here there in the picture, one of UNESCO's World Heritage Site, has a zoning density of up to 17,000 housing units in an integrated community. This picture shows you the proximity of the city. The 1 mile that you see here of the 1 mile and 1.6 kilometers road had to be built. It looks like in the middle of nowhere, but it's right in between Cartagena, which is the major city in one of the major cities in Colombia, and Turbaco, which is the capital of the state. So it's very close here, and it's bordering with the Cartagena country clubs. So it's a very good location there. The aerial photo shows the proximity, and we had to build also in this 1.6 kilometers the supply of water and electricity. And we built also a water treatment plant because there is no municipal sewage available. So in few words, the complete urban infrastructure had to be created. As everything Pasifos, it starts with the climate because of its geographical location over the tropical zone, and it's only 10 degrees north. And given that it is across from south to north by the mountain system of the Andes, Colombia has many climates according to its altitude, which are particularly constant throughout the year. This means that the most important characteristic when characterizing regional climatology is according to its topography. This linked to other environmental factors create the 6 natural regions of the country, and it makes 27 different microclimates, 5 in which humidity and rainfall intervene widely throughout its 1,142,000 square kilometers. The Amazonas and Orinoco basins built a hot, in some spots, very hot climate. The Andes zone, or the mountain zone, provides a great variety of climates from very hot to very cold. The East region is the Pacific region, provides a hot climate, and the Caribbean basin, it provides a hot or very hot and humid climate. And there is where our project is located. As you can see, this is the climate. We are dealing with dew points of 76 Fahrenheit or 24.5 centigrades throughout the year and throughout the months. And so it's what the meteorologists here in Vermont would call oppressive. Cooling demand is permanent throughout the year, as you can see here, and the heat losses are negative. So it's a totally inverse situation than what we have here in the Northern Hemisphere. The cooling conundrum that the world is facing implies that the global energy demand from air conditioners is expected to triple by 2050, require new electricity capacity equivalent to the combined electricity capacity of the United States, the European Union, and Japan in 2018. And it will grow to 5.6 billion units by 2050, up from 1.6 billion in 2018, which amounts to 10 new air conditioners sold every second for the next 30 years. And this comes from the report, The Future of Cooling, made by the International Energy Agency. Therefore, the reducing building loads is critical, and the passive house design can contribute greatly to this, and it's readily available. The project was supposed to start with these 3 buildings here, multifamily, 6-story, 48 apartments. But then in 2020, but then COVID hit, and we had it delayed the whole thing. And we are starting this year with this single family duplex type of houses called Guacamayas project at 27 units. So it's this shows you the rendering of the 27 single families, as well as the rendering of the 3. The development also includes 2 commercial buildings here. That's part of the zoning and the part of the permit, the building permit that the whole development has. The floor plan is very simple. It's a ICF of 100 square meters, 1,076 square feet. The second floor has 3 bedrooms, 2 full bathrooms. The first floor has 1 bedroom and 1 half bathroom, and then the kitchen and the living and dining room. The laundry, we decided to put it outside the building in order to be able to use conventional laundry equipment and avoid any possible penetrations that we had to make into the envelope. The standard common practice is a post and beam and reinforced concrete structure, and that presents, as you can see here, and that presents challenges for continuous insulation. So the common practice for interior walls in Colombia is to use an EPS board with a metal grid to hold a stucco plaster and alleviate the overall structural loads in multi-story building. So we are using the same component to create a continuous exterior insulation wall with a 10 centimeters, 4 inches EPS board lined with a 2.5 centimeters, 1 inch of stucco in both faces. That completely wraps the structural components, as you can see here in this picture. We'll bring it all the way down to the slab insulation. And this way we are adhering to local practices and locally available material, which is a very important thing. In this cross section, you can see the continuity of the insulation under the slab all the way up the roof, the walls. The wall is extended so it can meet the 30 centimeters, 12 inches of cellulose that we're going to be placing on the ceiling. So the post and beam structures are wrapped with EPS board for continuous exterior insulation, as you can see here, so avoid any thermal bridges that you may have with the structure. These boards are covered then with the stucco 2.5 centimeters thick stucco to make a complete wall. This picture, you can appreciate the raised insulation of the walls in here to accommodate the 30 centimeters, 12 inches of cellulose. And to support the cellulose, a blanket of Intelloplus is going to be laid above these beams and taped with Esconavana to the wall to make it airtight. Here you can also appreciate the finished wall, exterior wall of the with the plaster. Every 1,000 miles the trip starts with the first step. So these are the first 4 houses that we're building, and we are also building for experimental purposes and commercial purposes these 3 tiny houses with the same principles of passive house. For the slab, we required to put the insulation under the slab because the temperature of the ground is 28 centigrade, 82 Fahrenheit. This shows how the reinforced concrete slab is being poured on the EPS insulation board. For wall-to-floor interior joints, we will be using a 2 components non-sag water-based sprayable polymer that builds a rubbery elastic membrane with excellent adhesion to the surface. This is something that's being used regularly there in other construction things. So we're just adapting to the existing methods and existing available materials. This shows the 2 components. One is water, the other one is the emulsion. They are sprayed at the same time and we're going to be spraying them along the junction of the walls to the floor and the junction of the walls to the ceiling. For windows, the double pane windows are enough for that climate. The important thing is the low E-glass with a solar heat gain coefficient of 0.234, which is the lowest one that you can get. This is a solar band, which is a very high class glazing with international characteristics. We were very lucky to find a local manufacturer, local owned company in Colombia that has their own glass manufacturing here in the United States. And so we were able to source that locally. The windows are going to be fixed encasement and with insulated frames. Shading and dehumidification are the main tools in hot and humid climates. We have this is the Puffy model. We have modeled it, for example, with 2 meters, 6.5 foot pergola for the first floor living and dining rooms, which are the largest one, and we're taking this as the most critical one because this is exposed to the west here, so it's receiving the most radiation from the west. It originally had a window here, a second window. This room here, I eliminated it to reduce the solar gains. So by doing that, we can reduce 3.24 kilowatt hours per square meter a year, or 1.03 kilo BTUs per square foot per year in cooling demand, saving 373 kilowatts hours per year, or roughly $60 per year. In terms of ventilation, ventilation air is the main source of humidity. Therefore, it's necessary to minimize the ventilation volume to the 18 CFM per occupant that Phius recommends or specifies. So 4 rooms equal 5 occupants equal 90 CFM ventilation air. The dew point of outdoor air is 24.5 centigrade, 76 Fahrenheit. So the water content of 90 CFM of outdoor air per day will provide 187.46 pounds of water. So the desired dew point of ventilation supply air is 13 centigrade, 55 Fahrenheit. This is according to Lou Harriman, the humidity guru here in the United States. So the water content of 90 CFM of indoor air per day would be 90.26. So the delta water then is 97.2 pounds per day equals 97.2 pints per day. 1 pint is equal to 1 pound. So at first glance, the Minotaur with 112 pints per day seems okay. But since these conditions, this measurement taking at different conditions, we re-engineer this and we calculate the dehumidification capacity required for these 97.2 pints. which came up to 5,994 BTUs per hour. Then we also went back and re-engineered the Minotaur dehumidification capacity from this data to 4,534 BTUs per hour. So there is a shortfall of dehumidification by the Minotaur of 1,460 BTUs per hour. Originally, we had designed the ventilation with Ventacity ERV coupled with Fujitsu DX coil for dehumidification, but the integration of the two came to complicated, and also didn't provide the enough dehumidification, forcing us to have an additional dehumidifier inside, plus another mini split cooling only. So this shortfall will be remediated with a cooling only mini split that can take additional dehumidification and will be required anyway for sensible heat. And also, as well as by increasing the design dew point of the ventilation supply air to 15.6 centigrades or 60 Fahrenheit, which is an adaptive mode that, in my opinion, will be tolerable by the local community, considering that the outdoors dew points are 24.5 and 76. So we're running points from 76 down to 60, so that should be okay. And 9,000 BTUs mini split will have the dehumidification capacity of 1.5 pounds per hour. So that's more or less for close to 40% of this what we need. So that will take care of this shortfall, as well as any internal heat loads internal latent loads that we may have. This shows the ventilation ducts diagram. The trunks are 20 centimeters or 8 inches. The branches are 15 centimeters diameter, 6 inches, and the 8 inches are specified by Minotaur, so we're following their guidelines. And the twigs are 12.7 centimeters, 5 inches diameter. The ducts will be insulated with 4 centimeters, 1.5 of fiberglass pad wrap, so to prevent condensation. The Minotaur will be located here in the kitchen area in a cabinet. This is the best location we could find, because otherwise we would have to put it here in this closet, and killing the closet that would kill this bedroom. So, and this is the three-dimensional with the red the striped lines, and the blues the supply lines to the rooms and the living and dining room. For domestic hot water, solar hot water roof mounting system is going to be used. They are available from 100 liters, 26 gallons, to 300 liters, 80 gallons, and provide water at 90 degrees centigrade, 194 Fahrenheit. So this there is really not the domestic hot water is not really a critical thing, because nobody takes hot showers in Cartagena, but it's mainly used for dishwashing. Also, the tanks are on the outside, on the exterior, so that prevents any internal heat gains. And these are the preliminary WUFI results that show the target of 171.92 kilowatts hours per square meter per year, which are 54.5 kilobTUs per square foot per year. And the cooling load, the specific, is going to be 8.08 watts per square meter, and or 2.56 BTUs per hour per square meter per square feet. So for the 1,076 square foot, the total cooling load would be 2,755 BTUs per hour, which is smallest available non-duct mini split of 9,000 BTUs per hour can handle well and provide the additional dehumidification shortfall of the Minotaur. In-house testing, we're going to be doing it in-house because there are no available services there. As a matter of fact, in Colombia, you can obtain a LEED Gold certification without having to perform a blower door test. Those are the conditions. So we purchased a blower doors test system, as well as a vane anemometer to balance the ventilation air. In terms of the multifamily project, this is not part of the Phius feasibility study, but Phius has been very collaborative and very generous in terms of collaboration. This was a collaboration we had with them, with Phius, in 2019. At that point, we compared three different scenarios: a baseline, which is the standard construction there, the Phius 2018 scenario, and the Phius 2018 plus net zero. So we compare envelope, thermal bridges, windows, air tightness, ventilation, and the standard construction ventilation is not natural. So they turn on the AC and they open the windows to cool the Caribbean. So dehumidification, cooking is done by natural gas. So we're moving into electricity, getting away from fossil fuels, and laundry. In that case, we're considering condensing dryers because every single apartment needs their own laundry room. We also did an incremental cost analysis for net zero, starting with the baseline, and then adding the windows, the mechanical ventilation, the wall insulation, the appliances, and we got a big credit with the AC units because we're using much smaller AC units and less complex than the standard multifamily construction would have. So we came up with a 5% incremental cost for the Phius 2018 and a 9.7% incremental cost for the Phius 2018 plus PVs. In that case, the best option that we found for ventilation was DOAS, centralized on the roof, consisting of an ERV with a dehumidification coil to supply cool and dehumidify air at 55 Fahrenheit or 54.6 wet bulb. Each apartment will have also its own cooling only mini split. But depending on what we experience in the single family homes with the Minotaur, we may change the DOAS for decentralized ventilation with Minotaur, since this unit has been implemented already in many large multifamily projects here in the United States. We also did 6 cases comparison, improving the envelope to reduce the cooling demand as well as the site energy. And we found that the best cost effective was 50 millimeters, 5 centimeters of EPS, same board that you saw before, and medium solar heat gain coefficient windows, as well as a higher design temperature for the adaptive case, which would be this one. So at this point, I would like to give the microphone to Andrew, who will let you know a little bit more about the policies and commercial aspects of the project. Basically, I mean, the net zero building pilot program will apply a comprehensive approach to improving energy efficiency, establish an overview of sustainability and decarbonization for the building sector, which doesn't exist in Colombia, accelerate policy reform for new construction and plan for existing buildings, aim for rapid improvement in energy efficiency in new buildings, prioritize the use of renewable energy generated on site, and promote cooking, electrification, and appliances efficiencies, which is another important point. It's also, we're considering gray water reuse because we have our own water treatment plant. And also, we have been considering rainwater harvesting to supply the water for the gardens and things like that. This was Andrew's presentation here, so I'm not so sure what he was going to say here. So if he comes up, maybe he can explain what he wanted to say in terms of the right incentives that in Colombia you can have. And so in conclusion, the Puerto Madero pilot is intended to be a fully thought through mitigation pilot with activities based on real world context, which could be implemented in the future. So we are adhering to to common practices there and available materials. It's a totally different type of construction than we have here in the United States, which is mainly with wood. But it's very close to what the Europeans are doing. And Phius is collaborating with the feasibility study that could be to see with the best adapted to the climate specific and local building practices situation to provide various cost-effective alternative to reach the net zero goal.
All right, Enrique, can you please put up the slide if I can finish up this presentation?
Yeah. Okay.
Sorry, everybody. I don't know exactly what happened here. It was working at the beginning of the meeting today, so.
Right.
Okay, perfect. So yeah, our goal is to work on a pilot program for net zero energy buildings, and we'll apply a comprehensive approach to improve energy efficiency. So one of them is really to establish the overview of sustainability and decarbonization of the building sector. Now, to do that, transforming the building sector to a sustainable and decarbonized one means moving to net zero energy building. So in this respect, an energy modeling process like the one that Phius with WUFI Passive can define a roadmap that is applicable to different climate zones, different climate regions. So the first step in our perspective is to reduce energy waste by implementing, obviously, the Passive House standard. Now, the second thing, we need to accelerate policy reforms for new construction and plan for existing buildings. Now, obviously, new construction is a natural starting point of the policy intervention in the field of building buildings, since these are new infrastructures that do not create high levels of emissions or use energy. So their point is to minimize energy consumption to start with. In Colombia, there's regulatory instruments such as the Sustainable Construction Guide, which was approved in 2015, which is a good first step, but it's only a small step in the right direction. It's not enough towards low energy footprint in the building industry. The energy used by buildings is the sum of the energies used of several activities. So that's why a broad set of policies is necessary. This policy should cover first the improvement of energy efficiency in the design of the buildings, utilizing the tools like the Phius and WUFI Passive, and the reduction of energy consumption by the residents. Also in generating renewable energy on site, and of course the sale of that surplus of energy. And then of course one of the important ones is the electrification of energy use. So policies in new buildings must be accompanied by policies that promote renewable of the stock of existing buildings. And it is also here necessary to build a roadmap that is actually based on actual model and specific incentives that are depending on the context. So aimed at various actors such as owners, the tenants, the builders, or the renovation industry. So our aim is to rapidly improve the energy efficiency in buildings, and some of the specific policy regulations or recommendations that we're setting are to set absolute high performance goals instead of relative goals. So to mitigate performance-based approach like the Passive House standards, to make it mandatory for all buildings, to improve the efficiency levels over time. Now, for that, we need to develop also a strict compliance regime and define and implement protocols to comply for compliance that are similar to Phius Plus, raters, and verifiers, demand periodic collection and information. And we need to address the capacity deficits that is clearly in our market after that affect the compliance verification. We need to develop local capacity to implement and enforce the modification of new and stricter building codes. So we really need to work to make profitable the go beyond the minimum. And for that also we need to develop the quality labels that go beyond sustainable construction guide, which is what's set up by the government. And we need to define stricter and voluntary goals and incentives for builders to opt for them. We really need to prioritize the use of energy generated on site. We need to promote the installation of solar heating and photovoltaic panels, which is what we're doing in our project. We need to facilitate the connection of the network and net metering. That's something that we're working on. We need to formulate policies that ensure that the roofs of new buildings are prepared for use for solar energy. And we need to promote the electrification and apply efficiencies. We need to establish minimum energy performance standards for appliances and discontinue inefficient products. And we need to really test pilots like ours for gas replacements as energy for cooking, and based on the experience, scale back that initiative. I think Enrique went through the rainwater use and the rainwater harvesting. We'll definitely going to be implement those two very much. In terms of the rainwater harvesting, it's one way for us to reduce domestic water use. By harvesting the rainwater, we are using rain that is falling on the homes, on the landscape, or for a variety of purposes, and instead of making it basically becoming storm water or pollution. Harvesting the rain can reduce our need for the treated water, which is really important because obviously we have a treatment system on site for the water transportation, reduces energy, and the energy that requires that water into the buildings is going to be saved as well. In terms of the last part, which is next page, Enrique, is having the right incentives. Scale existing financial incentives and explore the use of non-financial incentives in order to increase adoption. Through the use of different interest rates, in this case, through the efficiency standards, tax deductions, simplification of permit procedures for highly efficient buildings, and others like donations and awards. In this particular example, this is one of the major financial institutions in Colombia. They offer a 1% reduction on loans for builders and 1% reduction on mortgage rates for buyers of what they're calling green homes, which are not even close to passive house standards, but at least they're going in the right direction, moving towards sustainable homes, or green homes as they call it. Our goal is that the passive house standard will become in the future, in the hot and humid climate zone that we're working on, the standard for real financial incentives in the market. So I thank you very much. I mean, I really appreciate the time that you've given us. We really want to thank again Phius for the collaboration. They've worked with us. Passive House Accelerator for having us and inviting us to present our project. And of course, the most important thing, I really want to thank the whole Passive House community. I think one of the things that I value the most, even though I don't join these events that often, is really the camaraderie and the shared, great, incredible joy that we see in this group, sharing the experiences, the learnings, and really just kind of the support that I can see coming from all of you guys. And really appreciate the Passive House community overall, and we thank you very much for the opportunity to present our project.